So, dear students, we'll now be doing the few questions which are given in the exercise at the end of the lesson. So, in case you don't have your textbook, kindly open your textbooks to page number 71. So, if you can pause the video, if you don't have a textbook, pause the video and open your textbook to page number 71. So, page 71, we'll be doing the fill in the blanks, okay, and the second and the fifth question, okay, which are like graph based questions which I feel are important. So I'll be discussing these questions with you all. So let's start with the fill in the blank. The first one is very easy. The amount of water vapor in air is determined in terms of its absolute humidity. The answer is absolute humidity. Second one, if objects of equal mass are given equal heat, their final temperature will be different. This is due to the difference in their what? The difference in their, we have learned in the difference in their specific heat capacities. So it is not capacity, it's a plural, capacities, capacities, okay. And the third one, during transformation of liquid phase to solid phase, the latent heat is what? The latent heat is very important. This is very important. Fill in the blank. During transformation or change or conversion of liquid phase, or what you call liquid state to solid state, the latent heat is released. It is released. Why released? Because it's the other way around. When the when you know when you whenever anything, I'll give you a simple very simple analogy. Whenever if you want to change a liquid to solid, let's say you have water, liquid water, and you want to change it to ice. The same thing like the fill in the blank. Liquid phase to solid phase, you are changing the, you want to change from water from liquid to solid state. What you'll have to do, you'll have to heat it or cool it. You're changing water from liquid to solid, of course you'll have to cool it, you'll have to put it in the freezer. Yes, you'll have to cool it. That means, so when you're cooling, do you supply heat or you take away the heat? When the substance cools, when the heat is taken away, in other words when the heat is released. So here that's why the answer will be latent heat is released. So just think about cooling, okay, just think about cooling, okay. So latent heat is released. But if the question was the other way around, during transformation of what you call solid phase to liquid phase, latent heat is what? There the latent heat will be absorbed. It will be absorbed because the solid ice, or the solid ice will absorb all the heat, and the temperature remain at 0 degree till the whole entire ice is converted into water. Is converted into water. Okay, so I hope this is clear. Okay, just think about this is very. Now let's go to the next thing. Now this is a graph question, very important. Observe the following graph. Considering the change in the volume of water as its temperature is raised from 0 degree Celsius or is above 0 degree Celsius, discuss the difference in the behavior of water and other substances. And what is this behavior of water called? That we all know, but we'll have to write it in a particular way. Okay, we just cannot say the answer directly. So as you can see, this graph is plotted of volume against temperature. Okay, volume of water against the temperature of water. As you can see, at 0, when the temperature is 0 degree Celsius, the volume of water is, okay, and it goes down. At 4 degree it becomes almost, okay, very at 4 degree Celsius the volume of water is the least, and then it goes up again. So how will we write this? So we'll see this. So I am going to go to the next screen, but you keep looking at your textbook and you keep listening to me also, okay, because I'll have to go to the next screen to give you the answer how to write it. So you'll have to write it this way. You'll have to say generally substances, or whatever, solids, liquids or gases. Now here water is a liquid, so I'm writing in bracket liquids. Generally substances including liquids, they expand on heating and contract on cooling. Next, in other words, their density decreases and volume will increase. So whenever a substance expands, remember the density decreases, volume increases. However, you will say water shows a special and exceptional behavior in the temperature range of 0 to 4 degree Celsius. So he behaves very abnormally. We saw in what temperature range of 0 to 4 degree Celsius. So if we heat water from 0 to 4 degree Celsius, as you can see in the graph, what happens? It contracts instead of expanding. It contracts. Can you see the volume graph? The graph was going down. Okay, it contracts. Next, in other words, what happens? The density increases and its volume decreases. The volume will keep decreasing. Volume will keep decreasing. At 4 degrees Celsius, the density of water is maximum and the volume is minimum because of maximum contraction. So volume is minimum. So if you see in your graph at 4 degree on the x-axis 4 degree, if you see the graph comes very low. It is at the lowest. Okay, can you see? Okay, so volume is minimum at 4 degree Celsius. It cannot be less than that. But if we continue heating the water further, okay, that is above 4 degrees Celsius, it expands like other substances. So as you can see, after 4 degree, you saw the graph is again going upwards. Okay, so water expands like other substances. In other words, it means the density decreases and volume increases. That's why volume is increasing. Can you see it is going up? So all the keywords, if you see, I have underlined it or made it in bold letters. Okay, and then finally you will say the behavior of water in the temperature interval of 0 degree to 4 degree Celsius is called anomalous behavior of water. So this is how you have to write the answer to question number 2. It's a graphical question. It comes at least for 3 marks. It comes for at least 3 marks, or it may come even for, who knows, it may come for 5 marks also. Okay, so very important question, graph based question. So please, you can pause the video here, and if you want, if you are interested, you can write down the answer so you know how to exactly write it down. So I'm going to pause here. If you, or if you, it's better you only pause, I'll go to the next question. Okay, you can pause, I'll go to the next question because we don't want to waste time. Now I go on to question number 5. Again, a graph based question. Okay, so I'm concentrating mostly on the graph based questions. Okay, so I did all the important, I'm doing the important question. The fill in the blank, I was interested only in the third fill in the blank, which is very important. Okay, now here we are going to question number 5. So I explain the following temperature versus time graph. So again, the same concept, but here the concept again is, it is based on water only. So it's a temperature versus time graph where the temperature is plotted on the y-axis and the time is plotted on the x-axis. So how do we write the answer to this? Now this question had come, if I'm not mistaken, last to last year in the board exams. Okay, this question had come in the last year. Okay, I think in March 2019, if I'm not mistaken, it had come in the 2019 or 2008. But this is a board question. This is a board question. This is a board question. Okay, so how are we going to attempt this? How are we supposed to write this answer? Now many students, they wrote answers, but most of them, they didn't know how to write it correctly, and they lost, most of them, they lost a few marks, or some of them lost all the marks. So I'll just give you the exact how the board expects you to write the answer. So if you want, again, I'm going to the next screen, but you keep your eyes on your textbook page number 71 and keep your ears focused on me. So I'm going to change the, because I'm just going to the next screen, that is the where the answer is given, how to write the answer. Okay, so how you'll write, will say segment AB shows that, can you see the segment AB on the x-axis near the origin? Okay, shows that at constant temperature at 0 degrees Celsius, okay, the temperature is at 0 only, ice changes into water due to latent heat of fusion. Fusion means what I told you, fusion means melting. Okay, fusion means melting. So segment AB shows that at constant temperature of 0 degrees Celsius, ice changes into water. I told you, remember in the lesson, when the temperature will not change till all the ice changes into water. Okay, and that heat which is absorbed is the becomes the latent heat of fusion. It's called the latent heat of fusion. Then water at 0 degree Celsius starts heating, and you see the graph. Then the graph goes up where it is written on the graph. No, that that part of the graph where it is written water and up and the liquid down, that slanting line. So that is okay. Then water at 0 degree Celsius starts heating, and its temperature gradually increases to 100 degree Celsius. And this segment BC shows the increase in the temperature from 0 degree to 100 degree Celsius. So once the ice is all converted to water, as shown in segment AB, now the temperature will start increasing. Till all the ice is converted to water, the temperature will not increase. Now in BC, once all the ice becomes water, now the temperature water will increase from 0 to 100 degrees Celsius, which is shown by B segment BC. Next one, can you see segment CD on the top there, where the CD on the top at the 100 degree mark? Can you see that? Above which segment CD, above which it is written boiling water plus vapor, or what you call steam. So that the segment CD shows that at constant temperature of 100 degrees Celsius, water changes to vapor due to latent heat of vaporization. Again the same concept, once the water reaches 100 degrees Celsius, the temperature 100 degrees Celsius, then the water temperature will not go above 100 degrees Celsius. It will remain at 100 only till the whole liquid water converts into gaseous state or becomes water vapor or steam. So till the entire water becomes steam, the temperature will remain constant at 100 degrees Celsius. That's why it says segment CD shows that at constant temperature of 100 degrees Celsius, water changes to vapor, or called water vapor or steam, due to latent heat of vaporization. No, we learned that. Okay. So I hope you understand how to write the answer. So this is how you are supposed to present your answer in the board exams or whatever exam, even your school exam. This is how you have to present it logically. Okay, don't just write any stories. Okay, this is a graph based question you have to write. So you can pause the video here and you can write down the answer if you wish to. Okay, this is given from the board format only. The board, it is exactly as per the board format. Okay, so please practice and please also go through the other questions. If time permits, we will discuss those questions also somewhere in the future. Okay, till then I stay till then you take care of yourselves. Okay, thank you for so we'll so dear students, thank you for your patient listening to this presentation on the chapter number 5, that is heat. And I hope things are now more clearer to you and you have understood better, hopefully. And in case, as I always say, in case you have not understood it still, kindly kindly rewind these videos and listen to it carefully, and maybe you'll understand better. And always, as I always say, before you start any lesson, studying whatever, always pray to God, ask for the God's grace, ask for God to pour out His Holy Spirit, His Spirit upon you, so that you understand things better. Okay, so pray and learn. You learn faster and you learn better, and you learn for lifetime. Okay, so as I and what as for the remaining questions, please go through them. Okay, and if you get a chance in the somewhere in the future, near future, hopefully we will discuss the questions. And if you have any doubts, as I always tell you, write it down and we will discuss once the school reopens. Okay, so hopefully we meet soon. Till then, stay indoors, stay safe, happy learning. Goodbye. God bless you all and your families.